Hello, Kevin Culp here again from Super Micro. Thank you for joining again. In the previous video, we discussed different architectures where JBOF rulers were interconnected to a fabric. In today's discussion and preview, we are going to discuss in detail lifecycle management for storage appliances, such as a JBOF, commonly referred to as just a bunch of flash, and JBOD, just a bunch of disks. JBOF rulers typically house NVMe drives, they're flash drives, and JBOD expansion units house SAS or SATA drives. So each of the drives are different that get associated with a chassis or storage appliance. Each of them have ideal, unique use cases. For example, an ideal use case for JBODs is object, block, and file storage commonly distributed across a distributed cluster, perhaps utilizing an open source implementation of Ceph. Another ideal use case for JBOF rulers is where protocol data transfers would be reduced, thus improving IOPS performance for bandwidth-hungry AI workloads. Super Micro caters to a wide range of storage appliances for the industry. I encourage you to connect into www.supermicro.com to learn more about storage appliances and their speeds and feeds. In today's demonstration, we've pulled into our lab an enterprise top loader and JBOF ruler where we will perform standard lifecycle management using SuperCloud Composer's storage module through its unified dashboard. So what you see in pod view here is a hallmark feature of SuperCloud Composer, where we visualize appliances that are inside racks within your data center. So what we see here is 3 pods that are identified. Clover Test, where there are 0 racks associated with Clover Test pod. We have a default pod where there's no racks that are associated, so it's just a group of racks within a common default location. And we have also a pod called Dock, where we have 1 rack that is associated with that pod or group. So for today's demonstration, ahead of time, we've created up front a number of racks. In this case, a bunch of storage appliances that are connected inside this rack we call JBOD. So you have a number of appliances that are inside this rack. It's a 42U size rack. So we start with 1 and then go to 42. So there are 42 rack slot units available within this rack. And you see here a collection of storage appliances associated with this rack. And by covering over each one of them using tooltip, you see various metadata that can be pulled from the appliance, such as in this one is a JBOF storage. It's starting at rack slot unit 5 and serial number and SKU information and IP address. The IP address is scoped through a DHCP server. So our BMC, you can define a static address to storage appliances or through DHCP. In our use case, we're actually receiving these IP addresses from a DHCP server that's inside our data center cloud environment or our sandbox. And we also have a JBOD storage, which is a serial number and also SKU. It's sitting at rack slot unit 14. So by being able to drag and drop them into this pod, we consider the form factor and also other various information that we pull from the source of truth being the BMC, which allows us to actually register within what we call the drawer configuration within PodView. We also have another JBOF storage here. So we have both a Gen 3 and Gen 4 JBOF storage. So our storage PMs had provided us these servers or appliances for validation. And then we also have another storage appliance, which is one of our new ones here, which is an ASG2115S, which is utilized a lot in AI applications. That's available to you as well. And then you see this little triangle icon up here. When a system is not been validated under SCC, we don't render the image. So we have a Visio template library in which we essentially pull the product SKU from and then visualize it within our library. This one is still under validation, so that's why it's actually showing a SKU image not available at this time. So we're continuing to validate storage appliances that our system storage PMs actually provide in the industry. So that's basically the front view. So I want to now kind of drill into the tree view. So the tree view here is showing you, again, all compute switches and appliances that are shown in the data center. So what we want to do is click on the default pod, and we see a number of those racks that were provided within our pod view. So we're going to select in the JBOF, JBOD, and then we're going to click on this location here, and then what that will do is now show us basically the front and rear view of the rack. Again, we created this rack ahead of time for this demonstration. Again, I mentioned it's a 42U size rack. We have no PDU information associated with this rack. If we wanted to associate PDUs, perhaps we have different zones within the rack. There are 4 zones, A, B, C, and D. We would, if we had a smart PDU that was inside that rack, we could associate it with this rack and be able to control the storage appliances within that rack. But we haven't associated any kind of PDUs. You can see here in the PDU rack, we have a little icon here to indicate that rack has a PDU associated and configured. So the next thing we want to kind of do here is look at, say, perhaps one of the drawer locations. So in this use case, we see a front and rear view. It's a JBOF itself. So we show serial number, the MAC address of the BMC. You can click here to be able to get into the JBOF itself through its BMC. We show the manufacturer, the drawer location. It happens to be a 1U, so the form factor is 1U, and so on and so forth, associated with JBOF information. So we can go ahead and uncollapse that, or collapse that, and then uncollapse, say, 14, and we can continue down to show different information associated with appliances that are inside our rack. This happens to be a JBOD for front and rear view, showing you the SKU. So this would be a top loader, the drawer height, ideal for Ceph storage, and the size of the rack. So that detail is present there. So let's now click on the storage module. So we identify the storage module through an icon, which is a disk. So by launching into the storage, module. Only storage administrators would have access. So you would identify or set up a role-based access control for a storage administrator to only be able to see metadata associated with the storage module. So it's important, again, we refer to that as the need to know. So building in compliance and governance within your data center is very important to SuperCloud Composer, and of course to administrators that are administrating the ops environment of your data center. So by clicking on the storage module itself, we're now going to pull up what we call JBOF information, or the JBOF storage list. So you notice here on the left, we only associate storage-related appliances in our particular tree view. So if you had a number of racks that were storage appliances, we would only show them in this tree view and filter them out. And of course, you would see a number of racks. We have one rack here that we've created here called JBOF and JBOD. We can uncollapse that, and we basically see two locations, 18 and 5. So that number 5, how did that come about? That's the rack slot unit location that we started with. So we associate those within a rack, and obviously you can't drag and drop into that rack slot location because there's already an appliance within rack slot unit 5 itself. So if you wanted to perform, say, a force power down of this appliance, this JBOF, we allow you to do so. We allow you to connect into its BMC. But the purpose is to perform lifecycle management and minimize the number of clicks for you to perform your task within the BMC. We provide that in our appliance or management SCC. So again, it's important to be able at scale to manage many of these JBOFs by a management platform itself. So by clicking on the BMC here, which is 200.200.1.9, we could certainly connect into the BMC itself. So we also provide metadata here, as well as you can see in our columns: BMC, zone count, endpoint, the number of SSD drives that can be in a root complex or inside this particular JBOF, the SKU, a serial number, and so on and so forth that we see in the list. If you wanted to look at displaying metadata that you wanted to see within your storage list, perhaps you were looking for something and you wanted to reduce or collapse the table, you can simply go ahead and click on serial number, and as you can see here, the serial number column is basically missing, right? Or we've hidden it in the background here. So this could be important to look at something that you want to filter on and be able to pull. Maybe you want to be able to search on all the particular JBOFs that are showing in a critical state, right? And provide that within your JBOF list, right? Or maybe you want to show a specific attribute of a JBOF you were actually looking for, perhaps a physical location of that JBOF. Because again, at scale, when you start looking at many appliances within racks, you could easily get lost to try to determine which particular appliance is associated with which particular rack. So it's important to see this metadata. All right, so let's move on to performing more of standard lifecycle management, perhaps day 0, day 1 operations. Maybe you want to look at information or drives that are associated with this JBOF itself. We provide a shelf information of these JBOFs itself. So you can see where 0, 1, 2, and so on and so forth have empty slots, so there's no drive associated with it. And then we have other slots that you can see here, 24 and 25, and 22 and 23. And then we have also metadata here to indicate BMC IP address, BMC version, zone count, so on and so forth, number of drives that are up and available, and the health score of the appliance and the power state. If we scroll down here within the drive list, we see drives that are attachable and ones that can be attached. So this happens to be a drive that is attached. Perhaps it's attached through a PCIe switch. And when you attach the whole entire drive, it's the entire volume. Whether it's attached through RDMA Rocky, such as a switch that's running, say, 100G or 400G, or perhaps through a PCIe switch like I mentioned before. And so this is completely attached. And we see the 4 terabyte drive, we see the temperature, the SKU happens to be an Intel manufactured drive, the part number, and the serial number itself. So by clicking on the item and showing the detail, the drive detail, we can go ahead and look at other metadata we want to see associated with the drive itself. Things like the media type is SSD, the protocol is NVMe, the capable speed. So all this information is being pulled from the source of truth, being the BMC itself, through Redfish endpoints, and then provided within our management platform itself. We can look at status information such as temperature and also help roll up. In the next video, we'll show you specifically monitoring detail information where we actually chart temperature through historical trending and showing you different ways that you can dump this information to a common delimited file. That will be in the next video. We'll discuss basically, say, day 2 operations for JBOD and JBOF a little bit later in another video to follow. All right, so this is the attached drive. So what do we want to see next? Well, we want to see attachable drives that are in our drive list. And so we have 4 drives. One of them has been attached, and that's the one basically that is highlighted. The other ones show hidden that are not attached, right? And so we provide that information within the visualization itself. So we color code them based on a dark blue indicating it's attached and a light blue indicating it's attachable or not attached yet. And then we provide, again, same kind of level of detail itself. This one showing a 0 temperature likely might be a little bit of a problem with that drive that we're experiencing. Wouldn't be seeing like a 0 temperature itself. So that's suspect of maybe we're getting perhaps a drive failure. We also see SKU, manufacturer, part number, serial number, and then we can perform what we call a drive erase too as well within the environment. If we click on the attach, go back there, and then click on the drive itself, we have an edit tag that we can go ahead and look at. So what is this edit tag or asset tag that is being presented here in this demo? And it really has to do with the application or what's on the drive. A lot of times you want to understand the application. Perhaps it's a scratch drive that you're utilizing. Maybe it's a backup drive, or maybe it's running a relational database or a SQL database that is storing this information. So it's important to identify that drive, what contents are on the drive, and then provide asset tag information associated with the drive itself. So we can go ahead and say perhaps we want to call it a scratch drive. In this case, we would type scratch. And then we would go ahead and save it at that point. And then it would now be identified as a scratch drive, right? Or any application that you wanted to associate this drive with, of what contents are on it. So that's a little bit of the JBOF itself. So the next thing we're going to do is take a look at what we call the JBOD storage itself. So JBOD being just a bunch of disk again, we're going to click on that option, and then it's going to provide us some very unique information associated with this JBOD. So JBOD, we show you the BMC firmware, the drive count within the JBOD, the health, the power status. Of course, we can perform a power down of that drive itself if we so choose, and then also SKU and serial number information. We also provide you with expander information. So in a top loader, we would have maybe disk expander units or expansion units that exist within the top loader. So we are identifying 2 drives that are associated with disk expander A. And if you wanted to perform, say, spinning down the drive itself, you could come over here and then initiate a power off condition. That would shut down the drive itself. Maybe perhaps you identified that drive as a problem, or you needed to maybe recycle the drive for some reason, or perform some type of life cycle management. Perhaps you needed to update the firmware or something else that resulted in you having to perform a change firmware or a spinning down of the drive. We can also go ahead and use the blinking, which is going to be unique for folks that have many disk farms that are associated with your data center. And by clicking on the yes option there, it would then submit a task and eventually would identify that particular drive to be, at this point, a drive you needed to perform or call out an individual to replace that drive, so that in the event that you needed to do any type of maintenance, right? Maybe perhaps you're looking at a bad drive and you want to be able to identify in your data center this big, large disk farm of multiple enclosures and chassis and multiple drives and a tremendous amount of racks to be identified. Your storage administrator go out and actually replace the drive. So really great nifty feature there in regards to identifying the drive that needed to be maintained. So the other option would be to go to your expander itself. So in this case, we have one expander. If we had multiple expansion units, they would be provided here in the list. And of course, we can also perform that, again, identifying the expander, and you want to maybe perhaps blink all drives. So maybe the expander is defective and you needed to replace the expander in a given appliance associated with a rack. You can go in and click on all drives to have UID blinking, so that that expander needed to be changed, or there was something wrong with the expander and you needed to identify it to being maintained itself. And then, of course, all drives for UID could be set to off too for blinking. And then you can also perform power management. So if you had a number of drives that were in that expander and you wanted to power down all the drives associated with that expander, you can come here and choose the option to say all drives to be powered on or powered off. So some very unique use cases there in maintaining drives within JBODs itself. The other option I want to show you is, again, the option to be able to reduce the amount of metadata that exists within your list. So by clicking on one of those options, you would provide less amount of data within the list. There may be an option here that you wanted to go ahead and perform. This option that I'm talking about of reducing the element list has been provided right across the platform of SuperCloud Composer. So things like you want to identify certain amount of information or metadata that is in your switch list or your compute list. We provide that capability and functionality for you to do so. And then, of course, the other option is using the search criteria, again, provided across the entire SCC appliance, as far as providing a mechanism to search quickly elements in a list. That can be very useful in honing in exactly which particular task that you want to perform within an appliance within SCC. So that wraps up today's discussion on day 0, day 1 operations. Thank you for joining today. I'm excited about working with the Storage PM folks. We are bringing out new particular storage appliances that have resulted in speed and feeds. Completely supportive of our storage positioning within Supermicro. Lifecycle management is that important aspect to maintain that level of high availability of your storage appliances and be able to monitor and manage them. Thank you again for joining. Have a great day, and we'll see you next time.